Let's take a look at real-life examples, equations for exponentials with and without shifted asymptotes. We're going to be reading context and trying to figure out which strategy applies. So as you read this first story and this second story, obviously you're going to want to compare the wording because the wording is going to make a difference. So the amount of juice made at the Juicy Juice factory increases exponentially each hour. After 3 hours of running the machines, they collect 825 gallons of juice. After 8 hours, they had collected 1,000 gallons of juice. Write the equation that models this data. There are some key words in here that give away how you're supposed to do it. Over here, example 2. A bottle of juice initially has a temperature of 70 degrees Fahrenheit. It is left to cool in a refrigerator that has been set to a temperature of 45 degrees Fahrenheit. After 10 minutes, the temperature of the juice is now 55 degrees Fahrenheit. Write an equation that models this data. Again, there are clues in here as well. So let's take a closer look. The amount of juice increases, and it says it increases exponentially. So notice that, increases exponentially. That tells you that if you increase with a multiplication-based rule, because exponential is repeated multiplication, and therefore you're going to have to calculate that by doing division. Division will undo the multiplication, and that will solve and build the exponential for you. So next, you should notice that we have no other conditions placed on us. So that is not a shifted asymptote example. Basically, this company is free to make as much juice as you want, and the curve for this graph is going to start low and slow and then curve up because it's going to be that exponential curve kind of a shape. So the equation is going to be of this format: y equals a times b to the x. Let's compare that to the other side question where now we have some detailed conditions in here. So notice the condition of left to cool in a refrigerator set to 45 degrees. If something is set to 45 degrees, then everything that's inside that refrigerator is going to eventually cool to that temperature. So that means it will eventually go to that temperature and not change anymore. This is an example of a shifted asymptote, as the temps of all items in the fridge will become 45 degrees. The other two facts given are just data points for the table. Since it has a shifted asymptote, you will be using a 3-column table. So the initial value that's across from 0 is going to be 70. 10 minutes is 55 degrees. You're going to put that data in the table. This middle piece of sentence here is a condition. That's why I wanted you to focus on comparing the wording. So back to the examples again. Now we want to write the equations for each situation. You can look at them both again, reread them if you need to. So what I did is I placed the data points of 3, 825 and 8, 1000 into the table for the given information. Then I knew that it was a multiplication-based rule because they told me it was growing exponentially, so I'm going to do next divided by previous. In this case, the gap right here is 5, so I'm going to take the 5th root. So I do the 5th root of 1,000 divided by 825, and I get 1.039. That's with correct rounding to 3 decimal places. Then I need to go back 3 spots to get to 0. You notice this jumps from 3 to 0, so I need to divide 3 times, which I can do that with this shortcut. So 825 divided by 1.039 to the 3rd power gives me 735.5 gallons, and that was the initial value. That's what they started with. So if I know what they started with, and I've already calculated what it goes by over here, this is what it starts at, this is what it goes by, and I have a complete equation to model this real-life situation. All right, there it is. Now, let's look at the other side. The other data that was given is that it was initially 70 degrees, so I put that in here. Then it was 10 minutes later at 55. We've learned previously that we have to take off the asymptote values. We need to remove those values, so you'll notice that this table is really important. The 0.25 and the 10.10 are the numbers we're going to use in our calculations. So I cross out that middle column. I solve using the other column. They are 10 apart here. There's a gap of 10, so I'm going to take the 10th root of next divided by previous, and I get 0.9124. Then in this y minus 45 column, it starts at 25 because that's what's across from 0, and it's multiplying every time by our multiplier that we already calculated, 0.9124. Now I've built this equation based on the y minus 45 column. Then I add the 45 to the other side, which would give me 25 of what it starts at times the multiplier, and then plus 45 as I move this over. So there's my equation. So I have an equation with a shifted asymptote for this example, and I have a regular equation with y equals a times b to the x over here. Now, you're going to be asked follow-up questions as you think about these real-life contexts. So here's your first follow-up. How much juice will the factory have after 20 hours? Well, if this is my table, I'm trying to fill in this 20, I've got to then use my equation to help me. So you simply plug 20 into the equation for x because you're trying to figure out in 20 hours in the x data points. Then I can solve for the y by just simply plugging that in. And when I do that, I would do the same thing over here on this particular problem because it's asking what is the temp after 20 minutes. So then I'm going to put the 20 in my equation over here. So you'll notice I'm plugging in 20, and that will find this missing value in the table. Then on this side, when I plugged in 20, I had 1580.9. On this side, I had 49. And then I've got those two things figured out. Now, follow-up question 2. When will the factory make exactly 2,000 gallons? Now that means when is this going to grow to 2,000? How many minutes is going to be over here? Well, clearly I can see it's going to take hours. It's going to take more than 20 hours for that to happen. Over here, when will the temp of the juice bottle reach exactly 52 degrees? Well, I know that would be somewhere between here. I know the answer is somewhere between 10 and 20. I just have to solve for it and figure it out somewhere in here. So let's take a look. So I set it up now as I'm finding a y value because I want to know when does it reach 2,000. That's why I put it on the y side of the equation, and I'm going to divide and solve and have to use logarithms. So I divide out the 735 on both sides, then I end up with these numbers. 2.719 equals our multiplier, and this is where logs come in. You need to log both sides, or you need to log base both sides, however you choose to solve these problems, and you end up getting x equals 26.145 hours. The other side is I'm setting the equation equal to 52 because I want my y column to equal 52, and I use all parts of my original equation. So then I subtract the 45, bring that over, that's where the 7 comes from. My next move is to get rid of this 25, so I'm going to divide that off. When I divide off the 25, I get 0.28. And then I'm going to have to now at this point, because I have x up in the exponent, just like we did over here, when you have x up in the exponent, you have to solve for it by using logarithms. So I'm going to use logarithms on both sides of this equation, and I'm going to get x equals 13.885 minutes, and that seems to follow the pattern here. But somewhere in between here, it was jumping to 52, so that answer is logical. That answer makes sense. Same thing with this answer. This answer makes sense because 2,000 would be down here, and it's got to be something more than the 20. So, in conclusion, look for a special condition of some kind that would affect all data points equally. Something that affects all data points equally. That would become your shifted asymptote, and you would take those numbers out so you could make your calculation. Now, this is the you try 1, and then you try 2. So here is a new story with 3 follow-up questions or 3 questions to go with it. Same thing over here, a story with a context and follow-up questions to go with it. And then you can enter these on Moodle when you're finished.